Hello everyone, welcome to our exciting online event on real-time analytics with Apache Pinot. And our speaker for the day is Barkha Herman,
Hey,
founder at Bit Voices and developer advocate.
hey, thank you.
Thank you, Barkha. Welcome. Now, moving to who we are and what we stand for. So, we are multi cloud for you. We are having more than 100,000 strong technologists from all over the globe. We specialized in multi-cloud strategies, data science, artificial intelligence, blockchain, and extreme engineering. We also help technologists to share their learning and to get opportunities through our platform, which is www.fifthia.com. Now, how we are growing. So we have conducted more than 1100 sessions till now, and we are having more than 400 speakers and 30,000 members who are associated with our platform. These are few of our master mentors who are associated with our platform. And these are few of our relationship partners who are Bata, Piper, Zera America, Alibaba Cloud, Odex Lab, Brilio, Dell, Microsoft, Multiverse, Persistent, Philips, Tiger Analytics, and many more. We are also an academic partner with Alibaba Cloud, and these are the few courses that we have done in line with Alibaba Cloud. And you can go through all these courses through our platform, which is www.fifthia.com. Now, how do we help? So we help in building your knowledge, digital presence, and helping you in orders when you are looking for a job through our community. We are a global data consulting and digital business transformation firm ranked by CIO Tech Outlook among the top 10 digital business transformation consulting startup in India. We are a community focused tech firm dedicated to aiding businesses in digital transformation through data engineering, automation, custom application, analytics, and science, demonstrated by ongoing community investments at www.fifthia.com. Now, as a part of our community, we'll provide a free certificate to all the registered attendees. So I request all the participants, attendees who have not registered for this event, please register to the given link, which is www.fifthia.com/event. And I will also ping this link in the chat box. And to download the certificate, we'll provide a secret code at the end of the session. Now, this is the sample certificate which we will provide you for the completion of this event. Moving to our speaker of the day, who is Barkha Herman. She is founder at Wit Voices, experienced developer advocate, speaker, technologist, podcaster. Her domain expertise are in analytics, big data, artificial intelligence, and for more information about her, you can go through her LinkedIn profile, which is mentioned here.
Good.
Now over to Barkha. Thank you,
Thanks.
Barkha. Welcome.
Hey, thank you, Prerna. Okay. So good morning, everyone. It's 5:30 a.m. my time. I know everybody over there, it's later in the day. I'm happy to be here. And today I'm going to be talking about real-time analytics with Apache Pinot. So a quick poll, and I'm not able to see, so Prerna, maybe you can help me. I'd like to know where are you in your real-time analytics journey? Are you just starting? I'm here to learn. Actively evaluating the technology options? Do you use Apache Pinot in production? Do you use Startree Cloud? And I'll talk a little bit about that. Or do you use any other real-time analytics technology? Or you have no plans for using it? Okay, with that, I'm going to start with Apache Pinot, fast, scalable real-time analytics. So what does that even mean, and why do we even need any of this? What is real-time analytics? What is Apache Pinot? Why are we here? Why are we even talking about this stuff? So you'll see that in this diagram, we have three buckets. On the left, we have streaming, we have batch, and we have like SQL sources. So Apache Pinot as a platform supports multiple types of streams, multiple types of batch ingestions, as well as multiple types of databases, including BigQuery, Snowflake, MySQL, and many more. And it collects data and it's able to serve data to user-facing analytics, anomaly detection, and business metrics and ad hoc analysis. So thank you for that. I see that somebody said that they're using Kafka, and Kafka is definitely part of the story here. So okay. So what is real-time analytics? Apache Pinot is a real-time analytics open source platform for lightning fast insights, effortless scaling, and cost-effective data-driven decisions. So, these are fancy words. You're thinking, okay, what does it really mean, Barkha? What are you talking about? So it was started in LinkedIn. So let me tell you the story of LinkedIn. So what happened was LinkedIn invented Kafka. Did you guys know that? Yeah. LinkedIn invented Kafka because LinkedIn, as a social media platform, was getting all these, it's an event-based system. So every time you go and like something on your feed or send a connection request to a person that you meet, hopefully you'll do that with me today, when you say, hey, go to Barkha's profile and say, hey, connect, what happens is there's an event generated, which gets put into a Kafka topic. Then the Kafka topic is picked up, is read by another application. Maybe it's a, connection request manager or a likes counter or whatever process. It'll pick up that message and then it'll put it somewhere and do something with it. So Kafka was invented at LinkedIn. And it's extremely efficient. It's very fast. So every time somebody does something on LinkedIn, an event is created, it's added to one or many Kafka topics, and then it's processed by many, many, many applications that actually do something with that data. And in LinkedIn, what was happening was LinkedIn was growing. There were millions of users. And we were using Elasticsearch to show stats. So how many of you have actually been on LinkedIn and looked at the Who View My Profile page? Anyone? So that page was being run using Elasticsearch. So thank you, Lyra, for raising your hand. That was using Elasticsearch to do the aggregation. How many people saw your profile? How many of them are actually connected to you? How many of them are of the title recruiter? How many of them are of the title CEO, CTO, hiring manager, things like that, right? So that was being run using Elasticsearch, and it was super slow. So Kafka was doing its work, but Elasticsearch wasn't able to keep up. As a matter of fact, when they were decided to create Apache Pinot to solve this problem, they were running 1,000 nodes in a cluster running Elasticsearch. And they were serving all these queries using Elasticsearch to find these roll-ups. And that is actually how they decided, okay, we got to do something. We have to invent something that's better. It's more real time. So as the topics are, the events are coming into the topics, we need something that can respond quickly. So as soon as one of you're sitting in India, I'm in the US, as soon as you click on my profile and hit connect, I get a message on my phone and the phone says, hey, so many people asked to connect, it's super fast. So when I'm looking at my profile page, I'm seeing my friend, my networking page, I'm seeing all these requests. That is a dashboard. And that dashboard is being rendered using Apache Pinot right now. So Apache Pinot, invented at LinkedIn. It's an OLAP data source, which was purpose-built to provide ultra-low latency analytics at extremely high throughput. So imagine how many people are using LinkedIn right now, and there are thousands of topics going, messages going everywhere, and they end up in the right bucket, on the right profile screen, and so on and so forth. So that was the origin of Apache Pinot. And also, now you're kind of going, okay, I get it. LinkedIn needs real-time analytics, but why do I need real-time analytics, right? Well, we are living in an on-demand economy. I don't know about you, but if my Uber is late, I get upset. If they tell me it's going to be 2 minutes, they better show up in 2 minutes, otherwise I get upset, right? So ride sharing is a great example. And as a matter of fact, one of our bigger users is Uber. Uber Eats uses, as well as Uber, uses Apache Pinot for a lot of their dashboards. And if you think about it, if you're looking at that Uber screen, that is a dashboard, right? It's a dashboard because it's showing you, your ride, who's coming, where are they? It's a dashboard. Social media, we talked about LinkedIn already. It is all most of the screens on LinkedIn are actually dashboard. So also Facebook, so also all the other socials, X and Instagram and so on and so forth. Mobile apps use real time because they need to show up to the minute data. News, traffic, weather are another example of on-demand economy. So they need real-time data. And we have a weather channel, a local weather channel that's using Apache Pinot as well. So they're using dashboards that need to be near real time. Video collaboration is real time. We have some platforms that are using for video collaboration. As I'm presenting this, I'm seeing these notices pop up that says, so-and-so is waiting in the waiting room. So-and-so has joined. So-and-so has said something. These are all real-time applications. Delivery services, food delivery services, instant payments, on-demand entertainment, online shopping. So you can see how a lot of our industries are implementing on-demand technology, and all of this is facilitated by real-time data. So it's time series data. What does time series data mean? It means that it's organized by time. When did it happen? So when I look at my LinkedIn connection profile, it's like in the last whatever day since you last logged in, how many people requested a connection? Or in a ride sharing, it's even more immediate, right? It's like, okay, in the last minute, where did the car move to? Is it closer to me? Is it, is it stuck in traffic? Things like that. Okay. What are some of the challenges of real-time analytics? So one of the biggest challenges when the engineers who created Apache Pinot were facing was data freshness. So in other words, if you click on, if I'm meeting you in person, let's say, and we're at a conference, and if you click on connection request for me, and I don't immediately see that the request is received, that doesn't work. If it comes 15 minutes later, we've lost that opportunity to connect, but it happens instantaneously, right? So the data has to be freshness. At a certain point, if the data is not fresh, it has no value. I'll give you an example. I was in Seattle one year and for a large conference, and I'm ordering food and they had a question for me. And I was able to answer that question right away using my phone. Now, imagine if that question was 15 minutes late. Well, I would have answered it, but it would be completely useless because in that 15 minutes, they would have already packed the food and sent it my way. So it wouldn't have worked. So sometimes data freshness matters because if the data is stale, it's almost useless. You can't use that in an interaction because a transaction even finishes between the time, due to the delay, so that message is lost. And then the other pattern, I don't know if you're familiar with this, how many of you have worked in a situation where you're ingesting streaming data and then suddenly somebody runs like a large query or ingests like, a terabyte of data on that same database, and suddenly the stream processing slows the heck down. And so one of the challenges is that we don't want that to happen. Even if we're ingesting large amount of data, let's say that we're updating all the menus for all the restaurants around the world and adding a new field to it. We're adding that while people are ordering food. We don't want that ordering food experience to slow down because we're making some bulk changes in the data. So that's batch ingestion disrupting data freshness, and we don't want that. Of course, query latency. We want queries to be sub-second fast. We want them to execute fast, and we want to support, complex joins, aggregations. I don't want to know, I don't want to wait for 2 seconds to get my screen updated. I want to know immediately what's going on. I want to know my data. So one of the examples of a client that uses Apache Pinot for real-time data is Stripe. So Stripe has petabytes of data. And when you're looking at your Stripe dashboard, it's not taking forever, even though the data is massive. And can you imagine how many businesses have Stripe dashboards and they're all looking at the same time? So the next thing that's challenging is high concurrency. So it used to be that we used to run reports or analytics for business stakeholders. So we used to have, managers, or let's say that Walmart, which by the way, Walmart does use Apache Pinot. Every store manager in the world wants to look at their sale for the last hour or last day. Every one of them is looking at it. Even then, that's just, let's say there's 10,000 stores, that's 10,000 users using it. Compare that to LinkedIn users, 700 million plus. So the scale is much different from 10,000 or even 100,000 to 700 million people looking at the data. So high concurrency is very important. Millions of users are using this. It's not just for managers, it's for users, it's end users. So the number of people using your analytics is everyone in the system pretty much. And then, there are other features like we want upserts, we want to have easy connectors for all kinds of data. We don't want to just limit what kinds of data can be put into Pinot and more. Before I go on, are there any questions? And I'm sorry, I can't see anything. So, okay. So let's talk a little bit about the Apache Pinot architecture. So as I mentioned, this was invented at LinkedIn. And if you've used Kafka, and I know they're moving away from Zookeeper now, but Kafka also uses Zookeeper, and it's built on top of Helix, which is a open source cluster management framework. So Apache Pinot uses this. It uses Zookeeper for keeping track of the cluster health and cluster status. And then it has a broker. So the broker is the query manager. So when you're running a query, let's say, give me all the restaurants in a 10-mile radius from my location, which is a typical query that I would want to do if I was ordering food, that would be sent to the broker. And then the broker would say, oh, wait a minute, her location is, Florida. So give me, for Lauderdale, Florida, give me the ones for this data. And so the broker will decide which server to send the query to. And then the server has the data related to that area, and it will return the results and to the broker, and then the broker will send it to the UI. And so that's the way it works. So the broker is your, brokers the scatter gather operations related to all your queries. And the real-time servers and the offline servers are two flavors of servers. So obviously this is a distributed system. It has a cluster, and the cluster has many servers. Each server maintains its own data. So the data is divided and in segment store, and there are different segments, and each server manages its own segments. It also allows for replication and redundancies, so multiple server can have copies of the same data. And the reason for that is if one server goes down, you have resiliency and all that good stuff. And then there's this concept of minions. It's not in this diagram that you're looking at. Minions are just workers. So if you have a process that says, hey, every 10 hours or every 2 hours, make sure that the segments are balanced, or if you have to rebalance segments or, get rid of some old data or whatever, that's what the minions will do. Okay. Any questions, guys? All right. So the next is, let's talk about the storage. So in Apache Pinot, I talked a little bit about it. It's a distributed system. It has distributed compute as well as distributed data. So this speeds up the process. This is what makes Apache Pinot fast, because, multiple queries can happen at the same time. They're not all running on the same CPU or sharing the same CPU, and they're not all querying the same data. Even the data is distributed. So a lot of stuff can happen all at once, parallel. So in Apache Pinot, there's the concept of table. So you can run SQL queries against a table just like you do in MySQL or SQL Server or, Postgres or so on and so forth. However, the table is just a concept. The table is actually comprised of many segments, and each of the segment is where the actual data lives. So why do you think that we segregate the data into segments? What do you think? So there's this concept in databases of sharding or replicating data, and because Pinot needed to address this high concurrency problem, we wanted to build a platform that was fast by default. And so the building block of Apache Pinot is these segments, not the table itself. The table is a conceptual thing, and you can still run query and the table will find everything. Each segment has part of the data, and it's more often than not organized by time, because again, we talked about data freshness. So if you think about it, I want to know where my Uber driver is or where my food delivery is, and it's usually not from 3 days ago. I have no interest in what happened 3 days ago. I want to know what's today. So if you think about it, it makes a lot more sense to segment the data based on time first, and maybe also location in my case, right? In the case of food delivery or Uber, it's location based. So the data is segmented based on not just time, not just what's happening right now, but also where am I, right? So And it makes for the queries to be faster and more efficient. And then there's this concept of deep store and Apache Pinot. Deep store may or may not be used all the time. You can create deep store in case you want to have recovery of data. If a server goes down and you don't have replicated data, you can go to deep store and restore it. Any questions on that? Okay. All right. Well, that's interesting. All right. So one of the other reasons why Apache Pinot is super fast is because it has these indexes. And as you can see, there's a lot of indexes, and we keep adding more. As a matter of fact, in this list, I'm not even listing vector indexes, and I'll talk a little bit about those as well. So we have many indexes. As you know, we started with Elasticsearch, and Elasticsearch has a lot of different indexes also. It has forward indexes and inverted indexes. So those are two flavors that also exist in Apache Pinot. And we have these indexes encoded differently. So in other words, you can configure a forward and back inverted indexes differently based on what kind of data you have. We have things like Bloom filter, which are statistical methods to filter out where things are not. This is very useful when you're doing aggregation. So I don't want to know everyone named Barkha, but I want to know how many places do an average person named Barkha lives, right? So that's an aggregation query as opposed to, hey, just give me everybody with the first name Barkha. It's a more complicated queries. Now, if I'm doing the query that's second, I want to know definitely which segments to look at, and it would help me a lot if I don't read all segments to get this data, right? So if I can narrow it down to most likely segments with the data, that kind of stuff happens using the Bloom filter. We have geospatial indexes. So geospatial, can anyone guess why we have geospatial indexes? I'll give you the answer. The answer is because Uber's using it. And Uber wanted to use geospatial because most of their data is location based. Yeah, exactly, geography, AK. We have JSON indexes, of course. JSON, a lot of the data we consume now is JSON, and parsing JSON at the time of aggregation is super slow. So what we do is we create these indexes that are able to flatten some of the JSON, and we can do a lot of rollups that are super fast, and you don't have to wait. Again, you have sub-second queries. That's funny. AK says JSON is the world. I'm going to assert here that vector is the world now, because as we move towards AI, we're moving towards vectors more than JSON. Not saying JSON is going away, it's not, but people are going to be using vector searches for similarity searches, and we'll talk about that a little bit. We also have range indexes. So I wanna have an index, but I don't want to say, oh, this message came at this second, this message came at this second, this message came at this second. I want to know, oh, give me everything that happened in the last 5 minutes. Well, a range index can address that. And then we have text search support. We have FST indexes. FST is actually allowing you to do regex on your query, on your data, which is kind of cool. We have timestamp, of course. We use a lot of timestamp data, so there's timestamp index. But then there's this thing called the star tree index. So I do want to talk a little bit about star tree index. So let's talk about that. So how many of you are familiar with cubes? Anyone? So I'll give you an example of what a cube is, right? So I see at least one yes, which is good. So what happens is that, let's say that I have clickstream data. So clickstream is, I have a website. I want to know who's coming to my website and where are they coming from and what browser are they using, right? So these are the three things. So if I was a clever person, I was like, okay, yeah, we're logging every visit, their IP, their browser, blah, 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 the header information, we're logging it. Instead of doing a query of how many whatever, how about we just create a bucket that every time somebody hits this page, it gets incremented, right? We'll create a bucket for it. So it's just a cube. It's cube data saying one more, one more, one more, one more. So now I have a counter. Every time I want to do how many people visited, easy. I just look at the counter and reset the counter to 0 every 5 minutes, every hour, whatever it is. That's cube data, roughly speaking. But usually what happens is we take the ton of data and then we create a cube based on it. So, let's say that our granularity is every hour we cube the data, right? It becomes super fast and you can create these fancy cubes and it's very efficient and it's very fast. So usually what happens is when we're doing analytics, cube data is preferable because now you're not scanning the whole database, then doing some addition or arithmetic, and then coming up with a number. Cube data is already there, it's already added, boom, you're done. The problem with cube data is that you have to plan the cubes. So you have to plan the cubes, and then you get into this situation where, okay, you have let's say that I want the granularity of every minute. Can you imagine how many cubes you end up with at the end of the day? It's unbearable. After a year, you're going to have, a zillion cubes. After 10 years, it's going to be even worse. Also, if you're cubing data based on, let's say, browser. So, a lot of the people are going to use Chrome, and then there's going to be that small section that's using the Arc browser or the Brave browser or whatever, and those are tiny little cubes. There's only a small percentage of people, but how many browsers are there? There's huge. How many countries are there? Huge. There's the traffic from, let's say, China, India, US is going to be large. The traffic from Kiribati, which is a small island nation in the Polynesia, is going to be very small. So you end up with these, thousands of cubes that are hardly ever used. Well, star tree index, what it does is instead of creating a lot of cubes based on every bucket, what it does is that it creates the cubes based on the most used buckets and puts the rest of the data in a star cube. So in other words, let's say that we have Chrome and Edge are the most used browsers. Then what it'll do is it'll create a cube for Chrome, it'll create a cube for Edge, and everything else goes in the star cube. So what happens is, think about it. Now we have only 3 cubes, and because most of the data is in the Chrome and the Edge bucket, those are optimized for speed, and so the results are very fast. But because the other cube is so small, let's say that it's 80-20. 80% is Chrome and Edge, 20% is the rest of it. Because the data size now has shrunk to the star, you're not scanning the entire database. You're scanning very small pieces. It's more efficient. And so now we have the star cube that serves the purpose of low latency queries at scale, and we're not stuck with these thousands of cubes, right? The same, and it does this at multi-level. So let's say that first D1, V1 is the Chrome bucket. Now, we also want to know that, hey, how many people came in the last hour that were using Chrome, but I also want to know which countries they're coming from. So let's say D2 V1 is India, D2 V2 is US, and D2 star is the rest of the countries. So you can have multiple levels, and this is how star tree index optimizes queries so beautifully. So one of the magic, this is an insider story. We have a team, customer success team, that actually helps customers onboard. And usually what ends up happening is we deploy Apache Pinot, and then, they start using it and it's like, this is great, this is great. And we want to optimize this one query that's kind of slow. Usually these guys go out, they implement a star tree index, and suddenly it goes, super fast. So most of the customers are like, what did you do? Did we lose all our data? The queries are too fast. It's because of the cubes. They think that, they've shrunk the data or something. But it's an amazing tool. All right, let's talk about upserts in Pinot. So we also have this feature. While this amazing GIF is playing, I'll talk a little bit about vector. I don't have a slide for vector indexes, but as of 1.2 release, Apache Pinot also supports vectors. And vectors are great because you can do similarity search against vectors. So what does that mean? Let's say that you have a Kafka topic that's coming in and it has articles. And so you have this article store and there are thousands of articles coming in. As you're ingesting the Kafka data into Apache Pinot, you can take that big article, convert it to vector, and save it in a column in Apache Pinot and create a vector index on it. Now you can do similarity queries against it, such as, hey, give me all the articles that you have that talk about analytics or business analytics, but you don't have to do a bag of word search, bag of word search will look for the word analytics in the article, or business analytics, or BI, or business intelligence, or whatever. If there's an article that talks about business intelligence and you're looking for analytics, it'll find it because we're doing NLP-based search. In other words, language-based search, not word-based search. So even though the word analytics never shows up in an article, BI, business intelligence, also means analytics. So it'll find those articles even though there's not, because that's how vector searches work. So, all right, any questions? I don't see any questions. So let's talk about upserts. So one of the things that we realized, Apache Pinot is a read-only database. So in other words, there's no edits, right? Because it's an analytics database. It's a give me all the data and give me, it's an OLAP database. It's for analytical processing, right? So it is actually for, hey, what happened? Give an insight into what happened. So typically this means that there's no edits, but we needed upserts. And the way it does upserts is that it adds a new row. And so when you're doing queries, instead of looking at the old data, it'll look at the newest data. And so what this illustration is showing you is that if you add a new row, segment 2.6, the metadata is what is updated. The actual row still exists with the old data and the new data, because eventing systems, the way they work is that an event happened, it's an absolute in time, and another event can edit it, but it can't change what happened originally. And so, yeah, you can replay the data and it'll still happen. And this is how upsert works. So questions about upserts, because it is a little complicated topic. Yay, nay? All right. All right, so let's talk about what we have been talking about a little bit. So Pinot's real-time capabilities, we have super fast queries, we have high concurrency, we can do batch and streaming ingestion at the same time, and the way we do it is we segregate both the data and the compute. So when a batch server is consuming batch data, writing it to batch segments, it's not interrupting any of the real-time stuff. You still get the same real-time performance as you do without the batch being handled. It supports upserts, it supports versatile joins, it has a lot of different indexes, and we're adding more as we speak. And the reason for these indexes is because data freshness and low latency queries are our bread and butter. So we need these amazing indexes to support that. It's built for scale. It is open source, by the way, so you can run it locally and you can do all kinds of stuff. And it is has SQL query interface. It supports SQL style querying of data. And it has a built-in multi-tenancy. I didn't really talk about the multi-tenancy in this session so far, but it's built from scratch because obviously you're going to want to segregate data based on either client or department or whatever, and that's built in. Okay. We also have a cloud offering, by the way. So we have the Apache Pinot is open source. You can play with it. You can run the Docker container today on your laptop, or if you don't want the headache of managing clusters and all this stuff, then you can use Start Your Cloud. We have a free forever version. So all of you who are listening about this, you don't want to install the Docker stuff, images locally. You just want to play with it. You can go to startree.cloud and sign up today. It's free forever, so you can use it, for as long as you like, and play with the tools. So I'm going to pause for questions here, and if not, then I'm going to do a small demo. Hopefully the demo works. Heyman says, hi, can you elaborate on how Apache Pinot and Microsoft Fabric complement or differ in handling real-time analytics? And how does Apache Pinot integrate with popular visualization tools such as Power BI? Yeah, absolutely. So look, I worked for Microsoft for 4 years. Fabric is like an afterthought. Apache Pinot has been around for a lot longer. So do they complement each other or differ? I think they differ from each other. And yeah, I think it's funny, this is an anecdote. I was talking about Apache Pinot at a conference when I met a guy from Microsoft and former colleague actually. And he was like, oh, so you're talking about real-time analytics. Tell me more about it. And that's because they were working on, the real-time nature of the Fabric stuff. As far as integrating with Power BI, it does. It supports pretty much all visualization tools. The difference is that if you're doing Power BI is robust in that it does a lot of its sort of, you can control in Power BI how much data you're bringing to manage better experience of dashboarding. So it's complicated. It's a rich ecosystem. It's been around for a long time. It's a great, great, great tool. And the problem though is it doesn't deal with, like, Stripe is not going to use Power BI for their dashboards because they have petabytes of data. Apache Pinot allows you to do that kind of fast querying. It's built into the system. It's already an OLAP. You're not trying to optimize it for rollups. And let me show you the demo, and maybe that'll help you understand that a little better. You're not relying on some dashboard designer to optimize your data. Apache Pinot does that for you. The dashboard designer just needs to do the dashboarding. So let's revisit this, and if we still have a question about it, so let's see if we can do this. All right, so before I do that, let me just show you where this is. So this is in GitHub. So if you go to github.com, star tree data, pizza shop demo, you can run this by yourself. So yeah, so Ake says because it's because it's built to hold the data and then display it. If it's real time, it's a little pain for sure, but it works with few ifs and buts. Yeah, absolutely. I don't think that Power BI was built for real-time dashboarding. It was built for analytics. And I think that they expected Power BI developers to be able to do the analytics stuff. And so that's why when they do run their queries, they can bring the data once and then run queries on top of it and all that kind of stuff. But in Apache Pinot, you don't have to do all those things. So anyway, so let's see if this runs. So let's do this. I'm doing this in front of everybody, so. Okay, so we're gonna go here and just to make and see if it's gonna do. So another question, Barkha, can you suggest some great real-time analytics reporting platforms that work with Apache Pinot? So yeah, Superset, if you haven't used it, we love Superset. Is very versatile. In this example, I'm using Streamlit. So Streamlit uses Python, and if you're a developer, a coder, Streamlit. So if you're a developer, Streamlit is easy for you, especially if you know Python. It's going to be super easy to use. Yeah, and it works. We have connectors for all kinds of other things. So, but yeah, Superset is amazing. If you haven't played with Superset, do. Okay, so let's see. It's doing stuff. Let's see if we can bring up localhost 9123. So this is what, okay, so this is the UI for Apache Pinot. Now it's showing that there's one controller, one broker, one server. It looks like there's one table. Should be two. All right. And by the way, here's the query console, so we can run some queries, and you can see that you can do, but we need another table. So let's look at the REST APIs. Actually, let me just do this. So I'm going to use REST API to create this order table. Control C. So let's do that. Bear with me. I know we may be at time, but this is worth it. All right, post. Try it out. I'm traveling, so I have only one screen, and that's always a challenge for me. Okay, let's go back to Apache Pinot and refresh. And look at tables. And look, there's a schema. Let's add the table real quick. There's the table. And all the definitions are in JSON, so they're very easy to understand. Let's go here, add find tables. Okay. Try it out. Execute. Perfect. Let's look and go to, oh, look at this. We have tables and it has data. And so let's go back here and go back to the README. And let's open this guy. $85.02. And check this out. So this is the Streamlit dashboard. And what it's doing is, I'm going to refresh it every 5 seconds. And here's your dashboard, and it'll, let's refresh it for every second. And what's going on? Here's the latest orders coming in. And look at this, most popular items, number of orders. So this is a roll-up query. It's saying, hey, what is in the last whatever time, what was the most popular order? And this is happening in real time, folks. If you don't believe me, here's the Docker stuff. This is a pizza shop demo. We just deployed it. And so we created this order service, which is just a Python script that's creating orders. And what it's doing, if I go back to my GitHub, what is happening is we have this order service, which is a Python script that's simulating orders in Kafka. And then we're using BiteWax to do some enhanced stuff for the enriched orders. So why the enriched orders? So we can have those pretty pictures that you're looking at. Because we have this products table also. And then we put it all in Apache Pinot, and Streamlit is the dashboard that's showing you what is going on. And all Streamlit is doing is querying from Apache Pinot, and you can kind of see it's pretty fast. This is real time running on my laptop. So yay. All right, I'm gonna stop because, especially the order service, because I don't want my my poor laptop to die. And you'll see when I run the query, you know, the total docs here have gone up. So this was 39 to a few minutes ago. If I rerun the query, there's 67. So it stopped. I stopped the order service, so there are no more orders. But you can see that we're handling a lot of data, even running one version of it on my laptop. So kind of cool, I think. What do you guys think? All right. So at this point, I'm happy to take questions. What do you guys think about Apache Pinot? It's free, so you can download and play with it. Or you can use StarTree Cloud and play with it on StarTree Cloud. I'm on Slack most of the time, so if you want to jump on our Slack, happy to interact. And I'm going to take a nap after this, but after that, I'll be on Slack. How do we install it on Windows? Yeah, it's very easy. So you can install the Docker container on Windows and run it. We also have Helm charts, so if you want to deploy it on Kubernetes. So I used to work at Microsoft. I have a Surface laptop as my personal computer, so I run this stuff on my laptop all the time. So using Docker. Yeah. So everything that I showed you, I'm on my work computer, which is an Apple, also works on my Windows laptop. Same thing. On Windows, you'll need to, well, and on, if you want to use Make, you're going to have to install Make on both of them. Or the quick start gives you the Docker instructions, and that works on both. So good question. Any other question, guys? It's super fast. It's super useful. Yeah. Yeah, so the Python part was just the Streamlit part. So if you're not using Streamlit, you don't have to. I used Python just to generate the messages, but you can use whatever you want. So it supports regular SQL. So as you saw when we were doing, this is regular SQL, select star from order items enriched. That's SQL. So yeah, good question. Yeah. So there's a REST API that allows you to do stuff that you can do all kinds of queries. We have a series of videos on how to do anything, but if you're getting started, I understand it can get a little, confusing. Feel free to jump on the chat. There's a very quick getting started. There's a ton of videos on how to do everything, so feel free to look at it. It's not as easy as SQL Server, but it does a lot more complicated things. So it is a cluster, so it's got a little bit more complexity, but a cluster that can live on your laptop, right? Yeah, absolutely. So join the Slack community. So if you go to dev.startree.ai, there's a community page, link for it, and the whole thing. So join the Slack community. It's very active. You'll find a lot of stuff. There's also a lot of sample code, recipes, how to do stuff. Yeah, exactly. And then also this QR code, by the way, guys, if you scan the QR code, it'll take you to a form. If you fill up the form, you'll enter a raffle to win a t-shirt, and we'll ship it to you happily. And also, there's my LinkedIn. So if you want to connect, I think we're at time, right? Verna, we're at time. Is it a 1 hour thing? Perfect. So stay connected. If you want to play with this, it's great. I love the platform. And if you have any questions, connect, ask questions. We keep adding more goodies to it. And you can contribute to it. It's an open source project, so play with it. If you like it, contribute to it. You're welcome. All right, so with that, I'm going to stop sharing my screen.
So thank you, Barkha, for giving such a wonderful and informative event. And thank you all the participants for joining us today. And this is the secret code here from which you can download your certificate. And you can also share the certificate on your social media platform. And I have also shared the guide of how to claim your certificate. So all the steps are mentioned in that guide. And still, if you have any issue, you can directly mail us on multiclouders@multicloudforyou.com. Thank you everyone once again.
All right.
Thank you, Barkha.